Good morning, students. Welcome to the third video of solving mathematics paper D, syllabus D, paper 2 4024, variation 21, October, November 2015. In my last two videos, I have done up to question number 7, and today I'm gonna do 8 and onwards. Okay, 8 says curved surface area of a cone is given pi RL. The diagram shows a solid cone with radius r centimeter, a height h, and slant height L. Suleiman makes some solid cones. The slant height of each of the cone is slant height, this L, is 4 more than its radius. So this L, according to the question, L is 4 more than the radius. Okay, it's saying over here 4 more than its radius, and use pi equal to 3 throughout this question. Show that total surface area of this one is something like that. Okay, so area is gonna be pi r square, the area of the bottom, okay, plus curved surface area, that's pi RL. Now pi is should be 3, then I have r square plus 3r, and then L is going to be 4 plus r. So simplifying this, 3r square plus 3 4s are 12r plus 3r square. So that's gonna be 6r square plus 12r, taking 6r common, so it's gonna be r plus 2, and that's equals to this, and it says that show, it showed. Okay, now complete the table for this. So what can I do? I can replace the value of r by 2 over here. So 6 times 2 square is 4 plus 12 times 2, that's gonna give me 48 over here. So that's 48, and when I put 3, 6 times 3 square is 9 plus 12 times 3, that's gonna be 90. Okay, now it says that on the grid opposite, draw the graph A equal to this. Okay, so I have the point 0 0, so I'll put this 0 0, that's the first point, and then second one is 1 by 18, 1 and 18, 1 and 18 should be, say that 1 2 3 4 5 6 7 8 9 10. So here I have 50, and then 10 small line like that divided by 10, so each is that 5 5 10 15 20. So over here is 118, 1 5 10 15 20, somewhere over here. And then I have 248, so this is 45, somewhere over here, 48. And then next one 390, so 390 should be somewhere 390, that's 100, this is gonna be 90. And then 4 144, so 4 144, that's 50, then this is gonna be 44, and then 5 210, so 5 210, 5, sometimes you know what, it's better if you go this way. Okay, that's 5. Okay, and over here is 200, 510, so right over here. And then lastly 6 is 288, so we're gonna go for 290, then we're gonna do little below, so that's 290 somewhere over here, so this particular place. So we can just join these lines. I'm using this thick pointer. Whenever you do with the pencil or pen, sharp enough so that it's gonna be a very thinner line. Okay, that's gonna give you correct to the nearest accurate value. The height. Okay, I have drawn that. Find an expression of for h in terms of r. So I had h over here. H is the perpendicular height, and I have over here r, and that's this. So h is gonna be L square minus R square. Okay, so what is L? L is 4 plus R. So 4 plus R square minus R square. So if I take this bracket off, it's gonna be 4 4 is 16, 4 2 is 8R plus R square minus R square. This cross out. So I'm gonna have square root 16 plus 8r. I can take 4 common. If I take 4 common, so it's going to be 4 plus 2r, and 4 is a square number, so it can be 2 4 plus 2r. I can keep it that way. 2 4 plus 2r. Okay, so that's done. Or we can write down 16 plus 8r. Now the height of the cone of this of Suleiman's cone is 12 centimeter. Calculate its radius. Now radius and height is given 12. So this is the height and radius. Okay, so I'll go, since h equal to square root, I'll go for this one. 16 plus 8r. 16 plus 8r. So it's given 12 equal to square root 16 plus 8r. To get rid of this square root, I'm going to put a square and a square over here. So it's going to be 144 equal to 16 plus 8r. So 144 minus 16 divided by 8. So r is supposed to be 16. So that's 16 centimeter. So that's done. Another of Suleiman's cone has a surface area of 200 square centimeter. Use your graph to find the radius of this cone. So 200 square centimeter, this is the area. So that's that. I'm gonna draw this line over here. That's gonna be area equal to 200 square centimeter, and that's gonna give me some values over here, and that's gonna be 4 1 2 3 4 5 6 7 8 9. So I got 4.9 centimeter. This cone is placed in a box of height p, where p is an integer. Find the smallest possible values of p. Okay, now this one is this cone. The cone is placed in a box of height p centimeter, where p is an integer. Find the smallest possible value of p. So smallest possible value of p. Okay, so what I'm gonna do, area, its surface area is given 200. So we know 200, and that's gonna be pi r square, and r we know that it's 4.9 square. And for formula of surface area, let me write down here. Surface area should be pi r square plus pi rl. Okay, that's the surface area of cone we're gonna use, total surface area. And then pi r is gonna be 4.9, and l we don't know. So 200 pi, remember the value of pi is supposed to be taken 3. So that's gonna be 3 times 4.9 square plus 3 times 4.9 times l. So l is going to be this 200 minus, when I bring this one, minus 3 times 4.9 square. Then this is gonna be that, and this part, let me write down 200 minus 3 times 4.9 square, and this part is gonna be divided 3 times 4.9. So divided by 3 times 4.9. So that's supposed to be approximately 8.7054. But that's my L, and as you know that in a cone, L is the slant height, this is the height, and this is the radius. So I need to find out h over here. That h is p. That's gonna be 8.7054 square minus 4.9 square. So this square minus 4.9 square, I got that. Then square root of that is gonna be 7.19. So 7.2. But look what this one is saying. It's saying that p is an integer. So I cannot take 7. If I rounded it off, it's going to be smaller than the height and the cone is not going to be fit. Okay, so that p is supposed to be 8 centimeters. So this is going to be 8 centimeter. Okay, so this is done. We're going to go for question number 9. And question number 9 is cumulative frequency. The cumulative frequency graph for the length of 50 tracks on Abby's MP3 player is shown below. Use the graph to find out the median, and we know the median is half of the cumulative frequency. That's 50 equal to 25. And if I draw 25 over here, 21, 2, 3, 4, 5. So 25 right over here. And then that's gonna give me some values over here. And this is in minute and second. So these are in minute. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 30 seconds is divided by 10. So 30 divided by 10. So each of this line represents 3 seconds. So I have 1, 2, 3, 4, 5, 6. So 6 3s are 18. So it's gonna be 4 minutes, 18 seconds. Okay. So that's gonna be the first question answer. The interquartile range, that's gonna be Q3. Interquartile range is gonna be Q3 minus Q1. And Q3 is going to be 3 by 4. 3 by 4 times 50. That's Q3. And 3 times 50 divided by 4, that's gonna be 37.5. 37.5. And Q1 is gonna be 1 by 4 times 50. So 50 divided by 4, that's gonna be 12.5. 12.5. So let me draw this. 37.5. So that's 37.5. So 30, 35, 36, 37. So 37.5 somewhere over here. If I join that, and that's gonna be this thing over here. And I got 1, 2, 3, 4, 5. So 5 3s are 15. So 430. 430 plus 15, 435. So 4 minute 35, 35, 1, 2, 3, 4, 5, 45. 45 seconds. Okay, that's for Q3. And Q1 is 12.5. So 12.5, 1, 2, 12.5 somewhere over here. And that's gonna give me 345. So that's 1 minute 0 second. All right, now this one is use the information of the graph to complete the frequency table for the length of the tracks. 2 minute 30 seconds to 3 minutes, that's 3. So upper bound or upper quartile, upper bound over here is 3 minute. So 3 minute is 3. Then 330 is 8. So 8 minus 3 is 5. So 4 minute is, I'm having here 18. So 18 minus 5 3 is 5 plus 3 is 8. So that's gonna be 10. And then 430 I have here, and that's gonna be 30. So 30 minus 18. Minus 18, that's supposed to be 12. So this is 12. I hope you understand what I'm doing here. And 5 minutes, that's gonna give me 1, 2, 3, 43. So 43 minus 30, we are going backwards of the cumulative frequency graph. Okay, so from that we are subtracting the previous ones and collecting the frequencies. And then 530 over here, then it's going to be 48 minus 43, that's 5. And then rest of them is 50 minus 48 equal to 2. So this is 2. This whole thing is supposed to be 50. 5 plus 3 is 8, 18, 20, 30, 43, 47, 43, 48, 50. So that's 50, that's done. Now, Abby plays 3 tracks from her MP3 player with no break between them. Given that no track is repeated, what is the maximum possible length of time taken to play these tracks? So, how many tracks she played? She played, Abby plays 3 tracks, okay, and they are asking that maximum possible length. So definitely 5 minute 30 seconds to 6 minute, that's her maximum, but I have only 2 tracks on that one, and another must be one from here. So this length is 530, one is 530, and 2 is 6 minutes. Okay, so that should be 2 of them 6 minute times 2 plus, and we're gonna take the highest values because it says maximum 530. 530, so that's going to be 12, and 12 plus 5, 17, so 17 minutes 30 seconds. Okay, Abby travels on a train from station A to F. The exact times of the train arrives at the and leaves station A and F are shown. So it depart from here, arrives at B at this, leave B at this, and so on. How many minutes did her journey take? So she comes from A to F. A depart here and F arrive over here. This is calculator version. So I can say 10 minute 21 second, and then minus 9. Actually, this is hour, 9 hour 58 minutes. So I got 23 minutes. So it's 23 minute. Okay. Abby starts playing tracks at random from her MP3 player as she leaves station A. What is the probability that the first track is still playing when she arrives at station B? So from here to here, 10:03 and 9:58, here is to 5 minutes track. Okay, 10, you can see that 03 minus 9:58. That should be 5 minutes. Now 5 minutes track still playing. So how many of them more than 5 minutes? Now more than 5 minutes, I have 5. See that? More than 5 but less than 5:30. And this is 5 minutes 30 seconds to 6 minutes. So 5 plus 2, 7 of those tracks. So this is going to be 7 by total track were 50. So 7 by 50. Okay, Abby plays 2 different tracks at random from her MP3 player. What is the probability that neither track is longer than 3 minutes 30 seconds? So neither longer than 3 minutes 30 seconds. This is from here more than 3 minutes 30 seconds. All of this. Okay, so we don't want that. We want something over here. 3 plus 5 is 8. So 2 of them. 8 by 50, and next one is 1 less from here, 1 less from the total, 49. And we have to see that 8 times 7, that's 57, and that divided by 49, so it's gonna be 4 by 175. Okay, so this one is done. Now question number 10. ABCD is a trapezium with AB parallel to DC, DC equal to 15, and AB equal to X. The perpendicular distance between AB and DC 3 centimeter less than its length of AB. So what they're saying, this perpendicular distance is 3 centimeter less than AB. AB is X, so this is going to be X minus 3. Okay, the area is this given 75. So area equal to 75 given, area of the trapezium. This is trapezium, and we know the trapezium's formula is half summation of the parallel lines, so X plus 15, and then times this X minus 3 equal to 75, taking to that side and multiplying this one out, X square minus 3X plus 15X minus 45, and this is gonna be minus 2 times 75 is gonna be 150. You can see that 75 times 2 equal to 150. And then over here I have X square minus 3 plus 15, that's plus 12x, and minus 45 minus 195, that's 150, that's going to be minus 195. So 195 equal to 0, and it is exactly whatever they are asking, so it says showed. Find AB given your answer correct to 1 decimal places. So we are using the calculator over here. Okay, this is quadratic equations using the calculator. Okay, you don't need to write down that. Okay, but just showing you that equation is 5 over here in my calculator, then 3, the quadratic. Coefficient of x squared is 1, coefficient of x is 12, coefficient of constant term x to the power 0 is minus 195. So this is gonna be x's value gonna be 9.20, and another value should be x equal to minus 21.9. Now the x is the length of the value, x is the value of the length, the length of this, so it cannot be negative, it's rejected. So I have x's value 9.20. Okay, now it says that AD is 0.8 centimeter longer than BC. Whatever BC, AD is 0.3 centimeter. Given that the perimeter of trapezium is this, so let's take this one A. BC is A, and AD is going to be A plus 0.8. So according to the question, A plus 0.8 plus 15 plus A, see that A plus 0.8, that's I have written A plus 0.8 plus 15, this is 15 plus A plus X, this is the perimeter, summation of all sides, equal to 38, and this is going to be A plus A, that's going to be 2A. Okay, and this is going to be 15.8, and X we got 9.20 equal to 38. Therefore A is going to be 38 minus 9.2 plus 15.8, oops, sorry, 9.2 plus 15.8, so minus 25 divided by 2, 38 minus that divided by 2, I should get 6.5, but they are asking us to find out AD. AD is A plus 0.8, so AD is going to be 6.5 plus 0.3, so that's going to be 6.8. Okay, so this is 6.8 centimeter. Sorry, this is 8, so that's going to be 6.5 plus 0.8, 7.3. This is 7.3 centimeter. All right. Now another trapezium LMNO has LM parallel to ON. The reflex angle, that means this angle over here, reflex angle LMN is 252. Calculate MNO, this angle equal to what? Now when I know this angle is 360 minus 252. So that's going to be 360 minus 252. That's going to be 108. And since these two lines are parallel, these angles are allied angles. So this angle MNO equal to 180 minus 108. So 180 minus 108, that's going to be 72 degree allied angle. Okay, so that's 72 degree. The ratios of the angle inside the trapezium are LON and LMN is 1:2, and LOLM and MNO 1:K. Find K. All right, so this one we know that. So angle LON over angle LMN we already find out 72 equal to 1/2. So LON equal to so 72 divided by 2, 72 divided by 2, that should be LON, and this is LMN is not this 108. This is 108. So this is going to be 108 divided by 2. So this is 54 degree. Okay. And then OLM, angle OLM. This OLM, since I know this one, LON, and this angle, allied angles. So this is going to be 180 minus 54. So 180 minus 54, that should be 126. Now it says OLM, that's 126, and then MNO, that's already we find it out 72, and it says 1 over K. So K equal to 72 divided by 126. 72 divided by 126, I got 4:7. So K, find K, 4 over 7. Okay, so this one is done. Question number 11, we got here, the diagram shows a solid triangular prism. The length are given in centimeters. Calculate the area of the cross section. So area of the cross section is area of this triangle. This is 50 degree, this is 4, this is 6. So area should be half times 4 times 6 times sine 50 degree. If I have this A, B, and this is theta, area of this triangle, the formula is half AB sine theta. So this is gonna be crossing out 12 times sine 50. So I got area should be 9.20. So this is gonna be 9.19, 3 significant figures, 9.19 square centimeter. Calculate the volume of the prism. That's very simple. Area times height or length. This time is length. So 9.19 times 20 times 20. I got 183. Correct to 3 significant figures. 184 cubic centimeter. Calculate the total surface area of the prism. Okay. So T has said total surface area. I know that area of this triangle, I have 2 of them. So 2 times 9.19 plus this bottom rectangular 6 times 20. 6 times 20. Then I have back there 20 and 4 plus 20 times 4. And then this front one, I have 20. I don't know this one. So I have to find this one. I know this, and this angle is given. So using the cosine rule, I can find out this one. Let's see. Let me take this one as M. So this M is going to be square root 6 square plus 4 square minus 2 times 6 times 4 times cos 50 degree. And I got 6 square plus 4 square minus 2 times 6 times 4 times cos 50 degree. Square root of that, I got 4.598. So that's 4.598. So what we got here? So 2 times 9.19 plus 6 times 20 plus 20 times 4 plus 20 times 4.598. So that gives me 310. So that's 310 square centimeter. Now a cylinder has a height 70 centimeter and volume 0.1 cubic meter. Calculate the radius. So radius is what in centimeter? So I have to change this one 0.1 and then 100 centimeter cubed. So volume equal to pi r square h. So volume is 0.1 times 100 times 100 times 100 cubic centimeter. And I need radius. So radius is over here. Bring this pi, and h is 70 square. So it's going to be square root. So r is going to be 0.1 times 100 times 100 times 100. That gives me that, divided by pi, then divided by 70, then a square root of that, I got 21.3. So 21.3 centimeter. That's my radius. Okay. Well, that's it. I hope you understand. If you have any question, leave it in the comment box. I'll get back to you. Thank you. Have a good day.